Okay, so section 9.6 is about inverse trigonometric functions. And what we're going to be talking about are tangent, sine, and cosine, but with an inverse. So inverse tangent, inverse sine, and inverse cosine. And those are the first three words up here in the vocab section. And we'll get a pen here to start writing. So the way that's expressed or written, or another way you'll see that, is you'll see the TAN abbreviation with a little -1, and SIN abbreviation with a -1, and COS abbreviation with a -1. Those three things mean tangent inverse, sine inverse, and cosine inverse. So these are the symbols that you'll see, especially when you're looking at a calculator. And what an inverse does is an inverse is the mathematical way to reverse something. So an inverse makes something go in reverse. So it reverses something. And we've seen this in math before, so I'm going to actually choose a different color here. And I'm going to show a couple ways that we've seen that, and I'll kind of put that over here to the side. So an example, again, this is not a trigonometric example. This is just a really old, so let's go x plus 5 equals 7 algebra example. X plus 5 equals 7, we have something plus 5. So to undo the plus, we've learned to subtract. And of course, we subtract both sides and you get x equals 2. So subtraction reverses addition. And we'll only do one other algebra example. Another example would be if you have x squared equals 9. So to undo that squared, what you do is take the square root of both sides. And on the left, you just are left with x. And on the right, you have a plus or minus 3, because those are the two numbers. When you multiply them by themselves, that gives you 9. So the square root symbol reverses or undoes the squared, the exponent. And so these are both examples of in math when you undo something, or when you reverse it, or when you take an inverse. And so now let's go back to our trig function. So with trig ratios, so let's look specifically at inverses as they apply to trig ratios. Trig ratios are coming from a right triangle. So I'm going to draw a triangle, and I'll call that ABC, just like the triangle in the example below in the notes. And I'm going to specifically look at just angle A. And so we can do sine of A, cosine of A, tangent of A, and we'll do all three, but I'm going to start just by talking about sine of A. So we're going to go sine of A. And sine of A is opposite over hypotenuse. So let's put some numbers to our example. Let's say it's a 3, 4, 5 triangle, which is a really common right triangle that we use, because we know 3 squared plus 4 squared equals 5 squared. And sine of A is opposite, so the opposite side, which would be 3, over the hypotenuse, which in this case would be 5. So the way when we do sine of an angle, it equals a ratio. In this case, for sine, that ratio is 3 over 5, which is opposite over hypotenuse. So that is what it means, or what we've talked about when we're taking a sine. And now what we're going to do, and I'll scoot up a little bit here, is we're going to do inverse sine. Well, inverse sine is just this thing in reverse. So the way I would write an inverse sine expression for this specific example triangle that we're using, I would do sine inverse of 3/5 is equal to A. And what that's doing is that's saying sine inverse of a ratio equals an angle. And I don't know where this extra word came from up here. So I said on the sine, I did sine of an angle equals a ratio. I don't think I need that word it. And then sine inverse of the ratio is an angle. So sine inverse of a ratio, in this case 3/5, because we're talking specifically about this example, equals an angle. So it's just going the opposite direction. It's putting the ratio on the inside of the parentheses, and then that gives you the angle measure versus our usual sine function. You put the angle inside the parentheses and you get the ratio. And you can see that down here in the formal notes section. So in the formal notes section, they're also looking at angle A, specifically at angle A, and they're giving you tangent, sine, and cosine with the inverse. So they're putting some math terminology with this, but ultimately what you've got here is, okay, we've got tangent inverse. Well, tangent inverse of BC over AC. Well, BC is right there, AC is right here, so that is opposite and adjacent, which is what tangent is. But now we're going to go tangent inverse of that ratio equals the measure of angle A. And likewise, we're going to do sine inverse. That one's opposite over, and here's our hypotenuse, opposite over hypotenuse. And then we do cosine inverse, and that's going to be adjacent over hypotenuse. So you're doing tangent, sine, and cosine inverse of the ratio, and that equals the measure of an angle. And let's go, and in this space down here where we have some notes, let's redo or rewrite our triangle that we had. So there's our right triangle. And let's go A, and we'll put a B, and we'll put a C, and we'll again do our 3, 4, 5. So on this one, if I again focus just on angle A, what I can write are 3 different inverse trig expressions. So I can say tangent inverse of angle, or I'm sorry, of the ratio, tangent inverse of the ratio 3/4. And that ratio is opposite over adjacent is equal to A, or the measure of angle A. And I can say sine inverse of 3/5 is A. And I can say cosine inverse of 4/5 is A. And this just follows our SOHCAHTOA that we did. So just as a reminder, I'll write that here. SOHCAHTOA. Once you have that acronym down that we've talked about, you have sine, cosine, and tangent. That helps you remember opposite and hypotenuse, adjacent and hypotenuse, opposite and adjacent. You're just undoing or reversing that process. And I can write these as fractions, or we can write it as a decimal. So I can take this tangent expression and I can say that's tangent inverse of 0.75. So I can write 3/4 as either 3/4 or 0.75. I can do that with sine, and that would be 0.6. And I can do it with cosine. So I can express it either as a fraction or as a decimal, and that's how ratios get written. And that's what these inverse expressions are. So you have your ratio that's in the parentheses, and then your angle is outside the parentheses. And what this is used for, where it's helpful, is what we can then do is go into your calculator. And so I'd like you to do that. And I've actually got your calculator right here. For most of you have some calculator that looks like this. What we're going to do is we're going to go in and get the inverse function. So you've got your sine, cosine, and tangent keys. But then if you hit the little second button, and I know it's different colors depending on your different calculator, you can generate a tangent inverse. So this is just the reversing of things. And then we can either put 3/4 or 0.75 on the inside. And when you do that and hit enter, it's going to give you a number. That number is the angle measure. So that is 36 point, and if we go to the nearest tenth, that would be 36.9. So I'll jump back here and say, okay, that means this angle A is 36.9 degrees. And that is what your tangent inverse, sine inverse, and cosine inverse keys do, is if you say, okay, I've got this triangle with a 3 and a 4. If I take the tangent inverse of 3/4 or 0.75, your calculator then knows and can tell you what that angle measure is going to be. And in truth, I'll jump back to the calculator here. We'll clear this. We should also be able to do second sine, and we had said in our example that was 0.6. If we've set everything up right, we better get the exact same amount, and we do. It's 36.9. It's the same value, and if we were to go to cosine, actually I'll clear this. If we go to cosine and we do what cosine was 0.8 or 4/5, we're again going to get 36.9. So we should get, and we did get, the same measure every time. And what that's saying then is, if we were to say, well, what is the sine of 36.9? Well, sine of 36.9 is the thing we've been doing in the previous sections. That better, if you punch that into a calculator, better generate 0.6. And it will, and we can go verify that really quick on here. We can say, okay, if we were to go the other way with this and say sine of, now we know the angle is supposed to be 36.9, and we hit enter on that one, there's our 0.6. And it's a little off on rounding because we cut the angle off at a nearest tenth, but you can see pretty clearly it's going to be 0.6. And I'll clear that key press history. So that's the idea of an inverse, tangent, sine, cosine. That's what they're used for. And we're going to jump ahead to the examples that fall on the bottom of the second page. These are the sorts of questions that you're going to get asked that go along with this particular piece of the lesson. So in exercises 1 and 2, determine which of the acute angles has the given trigonometric ratio. So we only have two acute angles, G and F. So we want to know where the cosine is 24/25. So it's either going to be the cosine of G, which would be adjacent. In this case, that's 7 over hypotenuse 25. So that's not it. Or it's going to be the cosine of F, which would have an adjacent of 24 and a hypotenuse of 25. So that's the one that gets us the 24/25. So our answer would be F. And that's a pretty straightforward question. The second question, number 2, is the exact same question, but they've made it more challenging because they put in a decimal. They've said 0.38. So we're going to have to do a little more work to get it. But again, only one of two answers. So it's either E or F. And we're talking about sine on this one. So sine of E would be opposite, square root of 2, over hypotenuse, square root of 14. And sine of F would be opposite, which would be 2 square root 3 over square root 14. And we can't see which one of those would give us 0.38, but we can just go into the calculator and check, plug it in. So I'll start with sine of E, which I think, if I'm not mistaken, ends up being the answer. So that's square root of 2 over square root of 14, but let's check here. So if we do square root of 2 over square root of 14, we should get that decimal. So let's see, second squared is our square root key, and that's 2. Then I'm going to arrow over, so I get my cursor outside the square root, and then I'm going to do divided by the square root of 14, and then I'm going to hit enter, and that gives me square root of 7 over 7, which is the simplified version of this. Most calculators, all calculators, have some way to convert that to a decimal. On this one, it's going to be the second key and the table option, and I can see the F and the D. That's fraction and decimal. So I'm going to hit enter on that, and you can see what it's going to do is going to take the fraction, make it a decimal, and there's our 0.3779, which would be, if we round up, 0.38. And so in this case, and I'll jump back here, our E angle is the one that gives us a sine ratio that's equal to the 0.38, square root of 2 over square root of 14. The final set of 4 questions, you're going to do all 4 of these the exact same way. And what that's saying is sine of some angle equals 0.2. Well, how could you come up with the angle? You just need to reverse it. And the reverse process is to write this as sine of inverse of the decimal or fraction is going to equal h. So sine inverse of 0.2 is h. So let's skip to the calculator again, and we'll clear out what we've got. I'll clear my key press history. So now I'm going to go second sine. That gets me my sine inverse, and I'm going to type in 0.2, and I'll close the parentheses and hit enter. And that means I have an angle measure of 11.5 degrees. So we'll go over here and we'll say, okay, that answers 11.5 degrees. Then we're going to repeat that process for all these. Tangent inverse of 1 would be our h. Cosine inverse of 0.33 would be our h. And then sine inverse of 0.89 would be our h. So 4 different triangles, 4 different ratios, and applying this idea of an inverse. So then I'm going to go in and I'm going to type tangent inverse of 1. So tangent inverse of 1, and I hit enter. That's going to give me 45 degrees. And I'm going to do cosine inverse of 0.33. So I'm going to clear this. Cosine inverse of 0.33. And we'll hit enter. That's going to give me 70.7. So I'll jump back here and say 70.7. And then the very last one, the sine inverse of 0.89. So I'll clear this out. Sine inverse of 0.89. And that is going to give me 62.9 degrees. So I'll go in here and 62.9 degrees. So 1, 2, 3, 4 angle measures. So that is the idea of how sine inverse works, cosine inverse, tangent inverse, and what they are used for.